Imagine waking up at 3 a.m. to a high-pitched whine. It feels like an ear-piercing alarm is going off in your bedroom, but you are the only person who can hear it. For many, that invisible alarm runs every hour of every day. The standard clinical narrative suggests this sound originates from physical damage. We are told that noise exposure or aging has destroyed the auditory hair cells in the inner ear, creating a permanent injury. Because the diagnosis focuses on the hardware of the ear, the treatments follow. Patients cycle through hearing specialists and sound therapy, spending thousands of dollars on devices built to address the site of the original injury. These interventions often fail to provide lasting silence because they treat tinnitus as an acute ear problem. For the chronic sufferer, the ear is no longer the primary issue. Most people fall back on acoustic masking, white noise machines, or bedside fans designed to provide external competition for the ringing. The limitation is built into the method. Masking devices cover the phantom noise while they are running, but they do nothing to stop the signal. The moment the device is removed, the ringing returns. This happens because of a misunderstanding of the underlying biology. Those damaged hair cells in the ear actually stopped producing the sound years ago. Since the ear is no longer the active generator of the sound, any treatment hoping for a real result must move past the auditory canal and look directly at the brain. When the brain is deprived of normal sound signals due to hearing loss, the auditory cortex undergoes a significant shift. It begins to sit in a state of sensory starvation. This triggers a compensatory mechanism called central gain amplification. To compensate for missing input, the brain turns up its internal volume, trying to hear frequencies it no longer receives. By increasing sensitivity, auditory processing centers fire spontaneously. This hyperactive electrical activity generates a phantom signal, a sound existing only within neural circuitry. This ringing represents an evolutionary adaptation gone wrong. The brain is attempting to find a signal that isn't there, and in the process, it creates the very sound it is trying to hear. Once the brain generates this signal, the limbic system gets involved. This is the brain's emotional center, responsible for scanning the body for potential threats. The limbic system intercepts this constant high-pitched ringing and incorrectly categorizes it as a biological danger. This categorization triggers a physical response, chronically elevated cortisol and a dominant sympathetic nervous system, keeping the body in a state of high alert. This cycle creates a trap. The stress response causes the limbic system to amplify the perceived volume of the ringing, which in turn generates more stress. Sufferers become stuck in a hyperactive autopilot loop. The brain has learned to continuously generate a noise and then stay in a state of constant panic because of it. Standard devices fail because they mask from the outside. To break the cycle, a treatment must work from the inside, forcing the limbic system to lower its threat flag. Research at Johns Hopkins into thousands of cases found a specific pattern in patients who achieved a meaningful reduction in their symptoms. The successful cases showed a distinct neurological signature: regular, sustained time spent in low-frequency brainwave states like delta and theta. This shift is physically measurable. As the brain enters these slower states, the hyperactive neural firing that generates the tinnitus signal begins to quiet down on the EEG. True relief comes from a protocol designed to interrupt the central gain loop by guiding the brain into these therapeutic slow-wave frequencies. This state can be induced through precision binaural beat generation, using calibrated tones to shift the brain's electrical activity. When each ear receives a slightly different tone, the brainstem perceives the mathematical difference between them. This triggers the frequency-following response. The brain begins to synchronize its chaotic electrical firing to match this slower signal, physically quieting the hyperactive loop. Through consistent use, neuroplasticity allows the brain to automate this calmer state, eventually replacing the hyperactive firing pattern it had previously practiced. Tinnitus is a learned, automated signaling loop. By targeting that process directly, the brain can be taught to stand down and finally restore silence.